Okay, in this class, we are going to discuss functions of R three variables and then the derivatives of the function. Okay, so in the functions of one variable means what? So suppose we have some set is a subset of R. Suppose we take J is a subset of R, be an interval. Okay, and then we define a function f from J to R. We say that this function is a function of one variable because the input is x, we get output is y. So only one input. The x is called independent variable. This y is called a dependent variable. Okay, only one independent variable we say is a functions of one variable. So and then we can discuss about the derivative of a point. Suppose if you have any point a in J. Suppose the function is not defined at a point A. Okay, so we can talk about the limit of a function at a point. So more generally, so the function may not be defined at a point A, but A is an element of J, but the function need not be defined at a point A. Then what is the limit of a function at A? Okay, so our interest in the for single variables, we talk about what is the limit x goes to a f of x, if it exists or not. Okay, so if you look at in the picture, so we have a two limit, right hand limit, left hand limit. Okay, suppose this is our j. The function need not be continuous, but is defined. Suppose if you take some point a in j, so we are talking about what happens if x approaches to a from the right hand side and then left hand side. Okay, so either is x approaches to this side, then what is f of x approaches? Suppose x approaches from this side, then what is f of x approaches? So we can say from therefore there are two limit. Limit x goes to a minus the left hand limit f of x. If it is exist, and the right hand limit x goes to a plus f of x. If it is exist, suppose both are equal, then the limit is exist and the value is nothing but the common value of this two right hand limit, left hand limit. Okay, so in the single variable we can talk about the limit. So similarly it's nothing but right hand limit, left hand limit. But so similarly again we can talk about the derivative of a function, all the things. Okay, so in the single variable function, so we can suppose f defined from J to R, even including the functions defined at A. So we are talking about the derivative of a point A. So it's nothing but if the limit exists. So limit h goes to 0, f of a plus h minus f of a by h. If the limit exists, and we call the limit is f dash of a, derivative of a function at a point A. And when we say, okay, this is if f is differentiable. So f is differentiable at a means this, if this limit exists and equal to this. So when we say f is continuous at a point A, if the limit x goes to a, f of x should be f of a. And we say f is continuous at a point A. Okay, similarly we can discuss all this for functions of two variables. So okay, now what do you mean by functions of two variable? The domain should be a subset of R2. Okay, suppose if we take some subset, let D is a subset of R2. Okay, now if we define a function f from D to R, so the range codomain always R. Okay, we say the function is called the functions of two variable. So f we call, or we say that f is a real valued functions of two variable, because real valued means what, the codomain is real, that's why we call a real valued two variable function or functions of two variable. We say that f is a function of two variable. Function of two variables. So usually, if you take any element in D is of the form ordered pair x comma y. Okay. So we have to assign some value because it should be the real number, therefore some z anyway. But the input is two input. So for example, if you look at the circular cylinder, okay, the volume of the circular cylinder is V is equal to pi r square h. Okay, if you consider the cylinder, so circular cylinder, okay, circular cylinder, everything shaded. So what is the volume of this is V equal to pi r square. Now here there are two variables r and h. Pi is a constant. Therefore, this volume is a function of two variables, that is f of rh. Maybe r square h or anything, but this volume is a function of two variables. Okay. Okay. Now we define what is the limit at a point in D. Suppose if you take some point a comma b or x x naught comma y naught or anything, then we can talk about what is the limit. Okay, so but here the some issues there. But in the single variable, there are two directions, either from the right hand side or left hand side. We will find the right hand limit, left hand limit. But here it's not the case. Suppose this is our R2. Okay, so we consider as our subset, D is our subset. Okay. Suppose we take this is our D. But we cannot draw the graph in R2 because it's, we can draw the graph in R3. But anyway, so if you take some point on D, suppose if fix some point x naught comma y naught, then what is the limit of a function at a point x naught y naught? So there are infinitely many directions to approach this point x naught and y naught. So either you can go this direction or you can come this direction. So there are so many directions to approach this point. Okay. So here it is not possible to find any right hand limit, left hand limit. But if you take the subset of R, we have only two limit, right hand limit, left hand limit, and then we got to check if it exists or not. If it exists, then limit exists. But in this case, if you take any point in the D, there are uncountable number of or infinite number of paths or ways, or we can reach that point x naught, y naught. So we have to check all the things. But so simply we can say, when we say the limit exists, so we fix some point. So let we fix some point x naught comma y naught in the domain D, but D is a subset of R2. Okay. Now what happened? Okay, function is defined. So f is defined on D to R. Is defined. Now we want to check what happened if a point x comma y, the general point x comma y, approaches to the point x naught comma y naught, what happened f of x comma y. Okay, so if the limit exists, then what is the definition? Okay, now what do you mean by this, and when this limit is exist? Again, this f need not be defined at a point x naught y naught. Okay, more even you can take that one. Okay, even the function need not be defined at, you can remove the point x naught comma y naught. So whenever we talk about the limit, the function may not defined at a point. But if you talk about the differentiability and the continuity of a function, the function should depend at a point x naught y naught. Okay, but for the limit case, the function may not be defined at a point. Okay, now definition for limit of a function at a point x naught y naught. So same definition as we discussed in the single variable. So we say that a function f of x comma y approaches approaches the limit L, approaches the limit capital L as x comma y approaches x naught comma y naught, and we say, and we write limit x comma y approaches to x naught comma y naught, f of x comma y limit is L. So when we say this, if take any epsilon greater than 0, for every epsilon greater than 0, there is a delta greater than 0, such that if you take any point x comma y, for any x comma y in D, okay, with that is, so if we take any x comma y in the domain F, we have whenever the, but here distance between x comma y and the x naught comma y naught. So we usually we not use we can use only the modulus, we can use only for the distance between real numbers. So more than two variables we use norm. Okay, so that is the distance. You can use the modulus, that is not issue, but modulus here means norm of vector. So that is, suppose if you take x naught y naught here, suppose x naught y naught has one point here, another point here, what is the distance between these 2 points? And we know that this is x1 comma y1 and this is x2 comma y2. So we know that the norm is x1 minus x2 whole square, square root of x1 minus x2 whole square plus y1 minus y2 whole square. Okay, so this is the distance between these 2 points. So distance means what? Modulus of this x1 comma y1 minus x2 comma y2. But usually we don't use this modulus. We use modulus only for the real numbers. Therefore, you can take the modulus, the norm, that is 2 perpendicular line. That is norm of the vector, because these are all vectors. That's why we use the norm. Okay, anyway. So whenever the distance between these 2 points x comma y and x naught is less than delta, so therefore the distance is nothing but square root of x minus x naught whole square plus y minus y naught whole square is less than delta, implies, but f of x comma y is a real number. So therefore we can talk about the modulus. So modulus of f of x comma y minus L is less than epsilon. So whenever the distance between x comma y and x naught comma y is less than delta, the distance between f of x comma f of y is less than epsilon. And this has happened for every epsilon and every point in the domain of x naught comma y naught, in the range of x naught comma y naught. Then we say that f of x comma y approaches to L as x comma y approaches to x naught comma y naught. Or equivalently, we can say this condition is nothing but, if you suppose you want to use the modulus, you can use 2 conditions. That is 0 less than modulus of x minus x naught should be less than delta, and 0 strictly less than modulus of y minus y naught is strictly less than delta, implies that modulus of f of x minus f of x comma y minus L is less than epsilon. Okay. So this is a definition for limit of a function at a point x naught comma y naught. If we exist, then this is the definition. Now we discuss some theorem. So first, what happens? Suppose we example. Suppose we define a function f from, if you take R2, it's not an issue, but if you take D or R2 anything, but defining R2 to R, defined by f of x comma y equal to just x, just a projection on the first coordinate. Now, suppose we want to find the limit at a point. Limit x comma y goes to x naught comma y naught. F of x comma y is nothing but just x naught. Suppose if we take y, then limit x comma y goes to x naught comma y naught, f of x comma y is nothing but y naught. So similarly, if you take any polynomial in the new polynomial function, just you got to substitute the values x naught, y naught. That's it. Okay. So maybe I can write all the things. So the next one is, suppose limit x comma y approaches to x naught comma y naught, y, f of x comma y is just y naught. And third example, suppose you are defining a function limit f of x is some k times x, k is some constant. So as x comma y approaches to x naught comma y naught, then it's a polynomial. Just you substitute the values x naught, y naught. There is no y here, therefore just k times x naught. So this is a limit. So now algebra of limits. Suppose we have a two function f and g, and suppose both limit exist, then what is the sum of the limit of a function? Suppose we have a two function and then limit exists. So limit x comma y approaches to x naught comma y naught, f of x comma y is some L. Okay. And another function g, that also the limit exists at a point x naught comma y naught. Therefore, whenever x comma y approaches to x naught comma y naught, g of x comma y, maybe we'll get some m. Now the theorem says, if you take the sum, so simply you can write the sum f plus g. So the limit f plus g should be limit of f plus limit of g, that is nothing but L plus m. Okay, that is f means what? F of x comma y. Okay, keep in mind. Again, this limit x comma y approaches to x naught comma y naught. So similarly, limit, if you take the subtraction of these two functions, the limit is L minus m. And take the product of this function, the limit also product of the limit. F into g is nothing but L into m. So if you take the quotient of this one, provided m is non-zero, then limit f by g is L by m, provided m is non-zero number. Okay. And suppose if we take some scalar, so limit some k times f is nothing but k times limit of f is nothing but L. And the sixth one is, these are all theorems. Okay. Suppose you have two integers, m and n are some integers, then what is the limit f of x comma y whole power m by n, provided m is non-zero. Okay. So m by n is nothing but L power m by n, provided this L power m by n is a real number. Okay. Sometimes you'll get a complex number because the square root of -2 something, right? Therefore, so this happen only when, so square L power m by n is a real number. So maybe you can say integers, and then n should be non-zero because we are defining m by n. So these are all theorems. Okay, now we discuss some examples. Find the limit of this one. So whenever we have a function, polynomial function, directly you got to substitute the point x naught, y naught in that function, you'll get the limit. Suppose otherwise the function is a quotient rational function. So rational function means what? Numerator is one function, denominator another function. Like this format, just to substitute x naught, y naught. If it is defined, you'll get some finite value defined function, then that is the value. If not defined, you'll get some infinity or anything. So you have to approach some other method. Okay. So if it is polynomial, you can directly substitute the values. So exercise first one. So what is the limit x comma y approaches to 0 comma 1? X minus xy plus 3 divided by x square y plus 5xy minus y cube. Now, this is a rational function. Numerator one function, denominator one function. Just directly you have to substitute x equal to 0, y equal to 1. In the numerator, we get 3 because 0, 0, 3. The denominator 0, 0 minus 1. Therefore, this is nothing but minus 3. Minus 3 is the limit. This is because it's defined. Numerator is a well-defined number. Denominator also well-defined number. Therefore, this is the limit. Similarly, if you take the another example, so what is the limit x comma y approaches to the point 3 comma minus 4? What is the f of x? So f of x is I take x square root of x square plus y square. So this is nothing but just to substitute x equal to 3. Therefore, square root of 9 plus 16 is nothing but square root of 25 is nothing but 5. So this is the limit. So limit exists. That limit is 5. But if you look at the another example, if you substitute the point, the function may not maybe sometimes not get the finite value. So for example, limit x comma y goes to 0 comma 0. X square minus xy whole divided by square root of x minus square root of y. So if x comma y approaches 0, 0, numerator we get 0, denominator also we get 0. So we cannot use this quotient rule. Okay. So however, we can simplify this function. So just you got to multiply and divide by the same number. So maybe I can write the next step. So the limit is equal to what? If you consider this function and then multiply and divide by the x square root of x plus square root of y. Okay. So just to multiply and divide by square root of x plus square root of y by square root of x plus square root of y. Okay. So in the numerator we have if we take x outside, we get x minus y in the first term, and the remaining square root of x plus square root of y. The denominator we have a square minus b square, therefore just x minus y. So we can cancel this x minus y. You will get just x into square root of x plus square root of y. Now if we take limit x goes to 0, y goes to 0, 0 plus 0 plus 0, we get 0. So that is a limit. Okay. You have to simplify it. Okay, good. Now, when we say a function is continuous at a point, so next, so this is a limit of your function at a point. Next, we discuss what is a continuous function when we say a function is continuous. So definition, a function f of x comma y function of two variable x comma y is continuous at a point, at the point x naught comma y naught, if first of all the function should defined at a point x naught comma y naught. So that is the first condition. If f is defined at a point, f is defined at x naught comma y naught, that is f of x naught comma y naught is defined. And the next one is the limit x goes to x naught exists. So the second condition is limit x comma y goes to x naught comma y naught, f of x comma y exist. And the fourth one is, if it is exists, that value should be f of x naught comma y naught. Okay, so that is limit x comma y goes to x naught comma y naught, f of x comma y should be f of x naught comma y naught. Then we say f is continuous at x naught comma y naught. So simply if you say f is continuous, then if it is continuous at every point. So the next note is, if a is, or see if f is continuous or a function f continuous, then it is continuous at every point. A function is continuous then it is continuous. Means what? Continuous means what? If it is continuous at every point. If it is continuous at every point in the domain. Continuous at every point of its domain. Okay. And then so we can use the chain rule also, but anyway, we'll discuss some example. Suppose f is defined from R2 to R2, sorry, R2 to R, defined by f of x comma y equal to 2xy by x square plus y square. If the point x comma y is non-zero, that is 0 is not equal to 0 comma 0, this one. If it is 0, that is x comma y, if it's 0, then it maps to 0. So function is defined for all points in R2. Now we have to show that this function is continuous at every point except 0. Okay. Why? So we have to show that f is continuous at every point except 0. At every point except 0 comma 0. So the first one is, first we have to show that the function is continuous at every point, every non-zero point, because for every non-zero value, we get the function is just 2xy plus x square plus y square, right? So if you take some arbitrary point a comma b where non-zero, so a and b are non-zero, then we have to prove that. So we first we start with the point a comma b in R2 and assume that this is non-zero. So non-zero means what? At least one coordinate should be non-zero. Need not be both. At least one A or B is non-zero, then the order pair is non-zero element. Now we have to show that this f is continuous at a point a comma b. So that means what is the limit x comma y approaches to a comma b, f of x comma y. So they directly got to substitute the values a b. You never suppose you get a positive number, then it is okay. So what will get 2 times ab by a square plus b square. So this is nothing but f of ab. Because in the denominator a square plus b square is non-zero number. Because a comma b is non-zero number, therefore a square plus b square non-zero number, therefore it's a well-defined number. So this is nothing but f of ab because ab is non-zero. So therefore clearly limit x goes to f of x, limit x comma y goes to a comma b, f of x comma y is f of a comma b, therefore f is continuous at a comma b. Therefore f is continuous at the point a comma b. So now we prove that this function is continuous at every non-zero point. We got to show that this function is not continuous at point 0 comma 0. Okay. So therefore we have to find what is the limit x comma y approaches to 0 comma 0, f of x comma y. You are not, if suppose you directly substitute 0 0, you will get 0 by 0. Okay. So therefore we cannot substitute the values 0 0 0 directly. So now how to solve this one? So anyway, we have to approach the point 0 comma 0. So there are infinitely many ways. So if you look at the plane, suppose this is a plane, so this is a point 0 0. So there are so many ways to approach this point 0. So if we take this straight line towards this also approaches 0. Or if we take this straight line, or if we take any straight line. So if you take y equal to x line, or this is y equal to 2x, or y equal to, so in general, if you take y equal to mx line, so anyway this line passing through origin, right? So we are considering this direction, m is any m. So along the path, suppose I am considering, we have to check for all points, for all direction. So specifically we have to check this direction also. So either this or this, because all the straight line. because everything's passed through origin, right? Therefore, what happened? The function at this curve. Okay. So first, what is f of x comma y along in the curve y equal to mx? So just to substitute y equal to mx. So what is f of x comma y? Is nothing but 2xy by x square plus y square is f of x comma y. If we consider this function in the line, y should be equal to mx. Therefore, we get 2mx square in the numerator. In the denominator, x square, m square, x square. So you can cancel x square. You'll get 2m by 1 plus m square. Therefore, you get 2m by m square plus 1. This is a value of a function along any line y equal to mx. Now, what is the limit? If you take the limit x comma y approaches to 0 comma 0 along the path. Okay, so along y equal to mx. I am considering only this. What is f of x comma y? Is nothing but just now we proved that 2m by m square plus 1. Because there is no x, y here, therefore we get just a number m square, 2m plus 2m by m square plus 1. But this is not unique value. If you change the values of m, you'll get different value. So suppose you take the along the path y equal to mx, that is m equal to 1, then you get one value. If you take m equal to 2, you'll get another value. If you take m equal to 3, you'll get another value. So for if you take any different line, you'll get different limits. Therefore, the limits are not unique. So when we say the limit exists, if you take any direction, the limit should be all limit exists, and then all the limits should be equal. So we are going to prove this limit does not exist. That's why I'm taking the particular path. Okay, I'm taking the particular path y equal to mx, proving this limit does not exist. You can take any other. You can take any curve also. Okay, need not be take the straight line. So if you take any curve, passes through the origin, and then you can derive the contradiction. So I am simply taking the line passing through origin. You can take parabola also, because all parabolas are passing through origin, right? So if you take if you consider this all the curves like this, that is y equal to m x square. You can take that also. Okay. So therefore, the limit is not unique. Therefore, f is not, the limit does not exist. Therefore, f is not continuous at a point 0 comma 0. Okay. So actually, there is a term, some test is there. The test is called the two-path test for non-existence of limit. Two-path test. Okay. So the test name is the two-path test. Two-path test for the non-existence of limit. Existence of a limit. Suppose you want to show that the limit does not exist, you have to take some path, some two different paths, and then you can say the limit different value, therefore is not exist. What is the thing? So again, if your function f of x comma y, if a function f of x comma y has different values, or different limits along two different paths, as x comma y approaches to the point x naught comma y naught. If you take any two different paths approaches this x naught comma y naught, and then this gives the different limit, then the limit does not exist. So then the limit x comma y approaches to x naught comma y naught f of x comma y does not exist. Okay. Now we discuss some example. So you have to consider two different path, and then you have to prove that it has two different limit. Therefore, the limit is not unique. Therefore, limit does not exist. So, for example, so what about suppose the function f of x comma y is defined to be 2x square y by x power 4 plus y square. Okay. So we have to show that this function has no limit at a point 0. So show that f of x comma y equal to this has no limit. As x comma y approaches to 0 comma 0. So we have to show that. So you have to take the limit. So you have to consider two paths. So there are two paths. Suppose you take a parabola. Okay. Suppose I am taking different parabola because all the parabolas are passing through origin. So therefore I am considering the path y equal to some k times x square. Okay. K is any number, but x is non-zero. But because if take x equal to 0, the function is not defined. Okay. So at least one should be non-zero. If x is non-zero, then automatically y is non-zero. Okay. So because this is a point x 0 comma 0. So you start from x comma y is because to approaches this. If you take some point here, approaches this. So if you take some point here, approaches. So therefore at least one coordinate should be non-zero. So anyway here, if you take one coordinate 0, other coordinates must be 0. So since this is a parabola, so therefore both the coordinates should be non-zero. Therefore this along this x-axis is not possible because everything is a parabola. So therefore everything is approaches to this direction. So that is y equal to kx square where x is non-zero. So along this path, so definitely this x comma y 0 comma 0. If x approaches 0, then automatically y approaches 0. So what is the limit? So there is directly substitute. What is the f of x comma y along the path y equal to kx square? You have to substitute y equal to kx square. So we get 2k x power 4 in the numerator. The denominator y square, therefore k square x power 4, and then you can take x power 4 outside. We get 1 plus k square. So therefore we get 2k by 1 plus k square. Okay. So if you take the different k equal to 1 or k equal to 2, if you take the two different paths, then you'll get different limit. If k equal to 1, we get 1. If you take k equal to 2, substitute here 4 by 5. So you get different value. So therefore, the limit does not exist. So specifically, if you take along the path y equal to, so if you take k equal to 2, along the path this one. So along the path y equal to 2x square, what is the limit of the function? So limit f x comma y is nothing but substitute k equal to 2, we get 4 by 5. So along this direction, the limit value is 4 by 5. Suppose if we take along the curve, along the path 3x square, then what is the limit? Limit of x comma y is just substitute the value k equal to 3, therefore 6 by 10. Right? Because 3 square 9, 10. So these are different value. So therefore, if we take two different paths, we get different limit. Therefore, the limit does not exist. Okay. Otherwise, therefore, limit x comma y 0 comma 0 f of x comma y does not exist. So no need to check all the parts. You take either because again the 0, 0 we can approach via the straight line also. Okay, but depending upon the function, so here there are some y square x power 4 is there, that's why I am taking parabola. So we can easily cancel all the variables xy. That's why I am choosing this curve. But in the previous problem, I am choosing y equal to mx. That's why, so depending upon function, we can choose the path. So that we can, if you substitute the values, all the variables are cancelled, we get the constants. So any doubt in this? So first you have to substitute the limit directly. If you get the finite value, then limit exists. The limit is nothing but the value. Suppose if you substitute the values directly, you will get some 0 by 0 format or anything by 0 format. Then you have to find the limit. Okay, so you have to choose some path, and then you have to check the this exists or not. Okay. So maybe quickly can ask some question. Example. So what is the limit of so actually x comma y approaches to 1 comma 1, the value is x square minus y square by x minus y. So what is the value? So in the numerator you can simplify it, x minus y into x plus y, x minus y cancel, we get x plus y. So directly substitute x equal to 1, y equal to 1, we get 2. Okay. Now second problem. Limit again x comma y approaches to 1 comma 1, but x not equal to 1. Okay, but x not equal to 1, you can allow y to be 1. So the function is xy minus y minus 2x plus 2 divided by x minus 1. Now what is the limit? So you want to approach the point 1 comma 1. Okay, so this is a plane. So this is a point 1 comma 1. So it's given that you are not allowed to go this direction, because if you reach this is a point 1, right? So you can reach the point 1 comma 1 via this line, but they said that you don't take that line, that is x not equal to means what, don't consider this path. Except this path you can take any path, so you can approach the point via this direction or this direction, x. Okay, you don't consider this line, okay, because this line x equal to 1. So you can approach this direction, or you can approach this direction, you can approach any direction to this point. So what is the limit? Don't consider this direction that is given, but x not equal to 1. So what is the limit? So you are not allowed to substitute the values directly, because if substitute x equal to 1, y equal to 1, the denominator is not defined. Therefore, you have to choose some path, and then you have to check what is the limit. So what is it? Any okay? So
Sir,
yeah.
sir, can we choose a path 0, 1?
No, 0, 1 means it's not a path, just a point. You're saying just a point.
Okay, sir. Okay, sir.
We need some numbers 1 by n or something. If vary, it approaches to that one. We need some constant. It should be varying. Y equal to m times x. Here m is a constant, is varying. Because y equal to x, if you consider y equal to x, because if you take y equal to x line, it always passes through 1 comma 1, right? So along the path y equal to x, because substitute x equal to 1, y equal to 1, anyway is approach to this towards this one, right? Because if you consider the y equal to x line, is passed through the point 1, 1. So along the path y equal to x, what happened? The given function. So this is f of x comma y. Then what is, if substitute x equal to y, what will get? X square minus x minus 2x plus 2 divided by, okay, this is actually x minus 1. Now what is this? X square minus 3x plus 2 by x minus 1. So again, you will not get anything, right? So is possible to cancel anything? No. So we have to cancel all the variables. Otherwise, okay, if substitute, okay, if you substitute, even if you substitute y equal to x or x equal to y, you get everything is 1. So if you take some other path, if you take y equal to x square or y equal to x cube, because everything, if both values are at the point 1, 1, both are equal anyway. So we have to take any path passing through 1, 1, and then you got to check. Okay, so can anyone or give any sequence is approaches to that one, that 1, 1. You can choose the sequence is approaches to 1, 1. That is coordinate convergent sequence. So maybe what you can take. So they give you are not allowed to take the first coordinate is 1. Okay.
N comma 1 by.
So, but n is not converges. 1 by n converges 0. Maybe you can take 1 plus 1 by n, because 1 by n goes to 0. Therefore, 1 plus 1 by n goes to 1. Okay.
Okay.
Or you can take the second coordinate is constant constant term 1, 1, 1 converges to 1, and here we can maybe you can take 1 plus 1 by n. So this 1 plus 1 by n is not equal to 1, right? So now we can take this sequence and then substitute here. What you'll get? Okay, so x value is 1 plus 1 by n into y. Y is 1 minus y, that is minus 1, minus 2 times 1 plus 1 by n plus 2 whole divided by 1 plus 1 by n minus 1. So if simplify this, what will get? Is equal to 1 plus 1 by n minus 1 minus 2 by n plus 2 whole divided by this 1, 1 cancel, we get 1 by n. So 2 cancel, and this minus 1 cancel, and this minus, what is this? You get minus 1 by n. The denominator we get 1 by n, cancel, we get minus 1. Okay. So therefore, if the limit exists, that should be minus 1, because along this path. Okay. So anyway, this is a path of some curve. Okay, along this, because we know that xn converges to 1, then xn converges to x, we have to check what is f of xn converges. Okay, that is usually we discuss in the first one variable, right? Suppose if we take some sequence f xn converges to x, then what happen f of xn approaches to. So that is the limit. But we have to check for any sequence converges to x. In particular, I am taking this sequence because why this is a sequence? Here the first two coordinates varying. Anyway, the second coordinate is a sequence. This is a constant sequence 1, 1, 1. So anyway, this approaches to 1, 1. Now substitute this sequence here. The limit should be minus 1. Now if you take some other limit, some other sequence other than this, instead of this one, if you take 1 minus 1 by n, that also converges to 1, 1. Okay. Now what happened in that case? Do you got it or not? But provided the first coordinate is never zone, so that's why I am subtracting here. 1 minus 1 by n is not equal to 1. So therefore, if substitute x equal to minus 1 minus 1 by n, this is actually minus. Okay. So therefore, this is minus, and this is minus, this is minus. So what happened? What is the answer? 1 minus 1 by n. Again, minus 1 minus 2 plus 2 by n plus 2. And the denominator we can cancel, we get minus 1 by n. So minus 2 cancel, plus 1 minus 1 cancel, and this is 1 by n. So you'll get again minus 1 by n, right? Minus 1. So therefore, we guess that we prove that this actually the limit is 1. Okay. So better what we have to do, you have to simplify this function. The limit is minus 1. So because if you take this limit, and if you take this sequence, we get again minus 1. If you take this sequence, again you'll get minus 1. So we guess that, okay, maybe the limit exists, that limit should be minus 1. Okay. Otherwise, you can prove this any sequence xn comma yn converges to x comma y. But so same thing what we discussed in the single variable, same thing here, but here we have to consider the sequence is ordered per sequence. So in the single variable, how we will check the limit? If you take any sequence xn converges to x, then we have to check what is f of xn. If all this converges to L, then L is the limit of the function at a point x. Okay, if you take any sequence. So if you suppose you want to find the right hand limit, if you take any positive sequence, that is any sequence xn which is bigger than x, but x converges to x, what is f of xn? If you are suppose you want to find the lower limit, if you take any sequence xn which is less than x, and then we have to check what is f of xn converges to. Okay, so here similarly, so if you take any sequence xn comma yn such that this xn comma yn sequence converges to x comma y. X comma y means what? Suppose you want 0 comma 0, then 0 comma 0. Suppose you want to find the limit, suppose x naught comma y naught. So if you take any sequence xn comma yn converges to x naught comma y naught, then what is f of xn comma yn? Suppose this sequence is converges to L, then L is the limit of a function at a point x naught comma y naught. Okay. Either you can use sequence definition or the original one. Okay. So if you take any sequence xn comma yn converges to this, then so maybe, but here we have to assume that xn is, in this example, we have to assume that xn's are not equal to 1. Okay, in this example. So if you take any sequence xn comma yn, this is a sequence. Okay, therefore I put 2 brackets. If you take any sequence xn comma yn, but xn's are not equal to 1, it's a non-constant, that is not allowed to take one sequence, but the sequence is converges to 1 comma 1, because we are talking about the limit of a function at a point 1 comma 1. Therefore, if you take any sequence xn comma yn converges to 1 comma 1, but xn is not equal to 1, what happened f of xn comma yn? So just what is f of x comma y? Xy minus y minus 2x plus 2 by x minus 1. So you can use the algebra of limits and then find the ln. So therefore xy xn comma yn minus yn minus 2xn plus 2 divided by xn minus 1. Okay. Now I think we are not using here for limit, because the denominator, we know that xn converges to 1. What happened? Xn minus 1 is converges to 0. Okay, suppose you want to apply the algebra of limits, the denominator should be non-zero, but here we get denominator is 0. Therefore, I think the limit does not exist. Okay, so you just try find a suitable path, you'll get a different value. Okay. Okay. Maybe I will discuss the other parts in the next class. So any doubt in this finding the limit and then finding the kind of check the continuity of your function? Either you can use the sequence definition or the original thing. Okay, both will get the same thing. Maybe I will ask one more question. Okay, all others are the partial derivatives. Okay. Okay, so okay, I stop now. We will discuss in the next class.